Hello, everybody, and welcome to the YouTube Model Builders Arduino Workshop with Chris of MRL Trains. Well, let everybody know, go to YouTubeModelBuilders.com. There you can find the schedules for the Tuesday, Wednesday, and the Saturday shows. Tuesday and Wednesday is 8 Central, 9 Eastern. The Thursday weekly show and the Saturday shows are at 9 Central, 10 Eastern. And also, while you're there, be sure and click on the eMag and get signed up for email notification. JD and his team do a great job on that. And they do such a good job. It's free and free of ads. Written by the community for the community. And let's see, anything else I got to say for right now? I don't think so. So, tell you what I'm going to do. I'm going to go ahead and throw Chris right on in the hot seat here. So, Chris, it's all yours now.
All right. Thanks, Johnny. Welcome back, everybody. I know it's been a little longer than usual because of the long month, the way the days fell. First and third fell last month, so it seems like it's been almost a month since we did this. But tonight we're going to do, in the true spirit of model railroading, we're going to do a freelance night. In other words, we're going to ad-lib it. I'm going to throw it out to not only the guys on the panel, but the guys that are watching on YouTube live right now. Post up what you think you want to do. We can do a review of anything we've done so far this year, or one of the ideas I just kind of thought of was actually taking that stepper motor and doing a turntable, one that actually would function. We could maybe cut out a circle out of a piece of paper and stick it on the stepper motor and maybe hook up some push buttons, or discuss how we would want to control that turntable and see if we can get something to actually function, because that's been one of the items that was higher on the list of everybody in general was a turntable, as well as servo control of turnouts and possibly signaling. So those are just some of the ideas. Or if there's any of the shows that you either missed or you'd like to go back and review and work on a little more, we could do something like that. But I think the whole idea tonight is we're going to just do this like true beginners, like we haven't done before. I apologize, I don't have anything prepared. I'm just coming off of being sick, and I haven't had any time. And then on top of it, my wife broke her ankle on Monday night, so I'm just absolutely unprepared for the show. So I think, it's a great opportunity for us to ad-lib or freelance this one, and give everybody, including the YouTube people out there, a chance to input and do what you guys want to do. So rather than me kind of lecturing, let's just work together, put our heads down, do a little research online while we're here, pick a subject, pick some code, splice it together, and make something happen. So with that, what do you guys want to do? I'll throw it out to suggestions right now. Anybody on the panel, or Johnny, if you want to watch the posts and see if anybody posts up any suggestions, if we hit one that sounds good to all of us, let's just go ahead and do it. Otherwise, no suggestions. Anybody you want to wander outside the box? We could try, Andy was talking a little about RFID. I think most of us that bought that kit from Frentali got some RFID components in there. We could try something like that. But the cool part is whatever we do, we'll just kind of do it from scratch, including the internet research that it takes to find pieces of code to use. And while you think about that, that reminds me of something. I'm going to show you. Every once in a while, when you're out on eBay and you just happen to run across a heck of a great deal. This is from Railroad Circuits. It's the equivalent of a PR3 in the Digitrax world, and what it allows you to do is create a LocoNet with your computer without having a Digitrax command station. So I just happened to score this one for a measly $12 plus shipping. I think it cost me $18 altogether. And if you go out to the Railroad Circuits website, this is a $64 item. So that was a heck of a score, I thought. So I can now set up a Digitrax LocoNet and start experimenting, even though I run NCE on my system. So that's pretty exciting. And this is brand new in the bag. The guy never even opened it, still has the staples in it. So pretty excited to actually give that a try, but I think in a future show, if there's enough Digitrax users that are following along in this show and want to try the LocoNet, that's something that we can definitely do on a future show. So thumbs up or just post up on YouTube if you think that's a good idea. If we want to experiment with Digitrax as a means to control some, using the Arduino and the Digitrax LocoNet, I think that's something cool we could play around with. So
what's the support for that look like? What's the support of the Arduino sketch space for Digitrax protocol support? I haven't looked as much about that as I have CMRI or MQTT or some of these other protocols, but what can you do with Arduino? Does Arduino speak Digitrax if they wrote the libraries for that?
There's a library. No, and I actually haven't looked into it since I got this, but I was looking into it probably 6 months ago, back when I first got the Arduino. Shield available, as well as a library. So there's a local Shield or something available to plug in on top of your. But I'm guessing if you already had a LocoNet in place, just say a command bus for your throttles, but you haven't incorporated JMRI yet. But what this would do, when we were talking a couple shows back about JMRI interface to create a network, with nodes to do signaling or throw turnouts or whatever through JMRI in your Arduino, could basically do the same thing on a LocoNet rather than on a CMRI network. So I think that's something pretty cool that we could mess around with. There's got to be some possibilities out there. So Johnny, were any comments out on the YouTube that anybody interested in? No? Okay. So I figured that summer is coming. It's about getting to be summer and people just start falling off of the hangouts during the summer. So,
well, Chris,
all right,
let me just throw something out there for you. You mentioned turntables, and I think one of the other couple weeks ago we were discussing some turntables, and I think just trying to figure out what might be better ways to specify the input. How do you want to, what kind of methods would there be to select which track you want to rotate to? And we could even go so far as to try and figure out how we want to detect where the turntable is actually positioned at the same time. So you really have a couple of different options there. How do you specify the input, and how do you control where the turntable is actually located?
So
those are some very valid points, because those are exactly the thoughts I was having as I was showing. Never got time to do the research, but yeah, there's a couple different ways you can do it. You could just push the button manually until you stop it. You could have two buttons where one goes left and one goes right. And those are assuming you don't have anything to line you up perfect. If you want to just do it manually, you could use a potentiometer and give yourself about 180 degrees worth of rotation.
Yep.
But also, like you're saying,
you can index it with a rotary encoder. So, I mean, with a stepper motor, you get fairly accurate, but it doesn't have any check and balance for calibration, so you'd have to calibrate it occasionally. So what I was thinking about, because I'm going to build my own mechanism as well, is using a rotary encoder around the shaft of the stepper motor as it goes up to the bridge deck. And use that rotary encoder, you can get that within sub a millimeter accuracy. And I've also found the math on deciding which way to go is not that hard. So if you could tell it to go to track 23 or 12, it can do some quick math and say, I'm here. Is it shorter to go this way versus that way, by justifying what is the smallest number? And then it would go. So it's pretty easy to let it self-determine direction. based on index and a pretty simple bit of math in Arduino that'd be pretty easy for us to share for anybody else who wanted to build them. The trick,
Or you could put, if you really wanted to complicate it too, you could try and do something similar to, I just call it the minivan door. You know, I mean, you push it most of the way, and all of a sudden it just slowly goes and latches in perfect position. You don't have to push it all the way shut. So it'd be the same thing. You push a button till it gets to the track you want, and when it's approximately lined up on the track, you let go of the button, and then your indexing step would just grab it and slowly move it to the final position exactly lined up.
I like
Why
that
even
idea.
bother holding the button? If you triggered the button, you already got a sense, you know, in your code, you've already picked up the fact that you pushed a button in the direction
So now
you wanted it. You could even let go of the button and continue processing.
That adds another layer of complexity because now you have to tell it which track you want to stop it at, because we're assuming you might have 8 or 10 different tracks, and it might be 8 tracks away, you know. So just
But
hitting
here
the
comes
button to move doesn't tell it which one to stop at.
Got a
Right?
Right, but then
comment.
you have to have known positions for you. I mean, either case, you have to have known positions for you where your tracks are going to be. Right?
There's a harder
Yeah.
problem to solve too. With the turntable, you don't just specify what track. You specify which side of the bridge goes to which track. Because there's
Yeah,
you know,
that's
you may
true.
want to pull a locomotive out and spin it around. So what I've thought of doing is either doing push buttons on a control panel for people who like control panels, or in my case, I'm gonna use reed magnets on the layout used by a magnetic coupling wire. Just hit the magnet on the bridge and then hit the magnet I want it to go to. It will take those two inputs and tie them together. But you can do that with a control panel where you specify where you set the bridge and you specify this track or that track. Or the way a lot of DCC systems do is they have a little house, a little control shack on the deck, and they'll call that the A side. And so if you have 6 tracks over here, they'll put 6 positions over here, even if there's no tracks. So if you want the control side, the A side, to go to this track, then just press that button. But if you want the B side there, you press the button opposite it. So it's pretty easy to do it from a button input perspective. And then if somebody wanted to use reed switches and magnets, it'd be just as easy. But if you don't specify track, you eliminate the ability to automate its function or to be able to control it from your throttle with DCC.
But Andy, are you indicating
also
one
have-
for each track?
I'm going to what I'm going to do is put a reed switch between the ties at the right, you know, second tie back or first tie back right at the edge of the bridge. So I'll tack the bridge and tack the track with my magnet. That's how I'm doing my turnouts as well. But they electrically work just like a momentary contact push button. So there's no difference in wiring or code or anything to use a reed switch or a push button. I just want to hide them. And reed switches make it easy to hide.
Yeah,
Got a comment.
in the Arduino world, it's just an on-off. So yeah, go ahead, Johnny, with the comment.
I got Brunette 42. When y'all first started on this, said stepper motor for turntable, servos for switch control. Then he said, good idea on what David said. And now he's saying different shields, i.e. motor shield.
Oh, okay. Yeah, we actually did use the motor shield in both the servo and the stepper, which
And
is kind of neat. It's a dual purpose piece. So, a shield actually,
Yeah.
not
that's
just
that's a true shield with the servo controls and everything. I use it on my DCC arrangement. Motor control shields makes things a lot easier from a wiring perspective, but from a code perspective, it just depends on how much of it you use.
I was talking about the driver board, the stepper motor driver board that also works for servos that we use for both of those projects. So
When I ordered some of that magic wire, they call it, but it's Cantham wire or something like that, something like that, that is electrically actuated. And I'm going to try building turnout mechanisms with that as opposed to servos, because the servos are just so doggone loud that, and with that electrically actuated memory wire, it's dead silent in every way. And then I could stick these little 1-inch speakers I was showing you guys a minute ago. I could stick one of these little 1-inch speakers under the thing, and then I could put some, go out and record the sound effects off from a hydraulically thrown turnout, and you'll get that chink, 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 chink.
no, there you go. Interesting. So with that being said, I guess what do we want to dive into tonight? Or do we want to?
You got to
Well,
index it.
Yeah.
Yeah.
Well, Andy's
Well, you can. Okay, so the question was, how would you out from the chat room was, how would you index the turntable? And there's a couple different ways. Andy was talking about one good way to do it. Another way is do it the way they did it in the prototype. That's manually. You know, if you think about it, depends on how prototypical you want to be versus how much down the rabbit hole and how complex you want to make it electronically. But if you're doing an older layout, you know, a lot of times they were literally pushed by a guy by hand.
It depends on what you're recreating, too. Yeah, what you're modeling.
It depends on your era.
And kind of missing, though. One of the things we're missing with alignment, though, is you could easily just do an optical alignment, have an LED in either the turntable and have sensors under each one of the tracks so that when they line up, when it senses the LED, it knows the track is lined up.
So
there's
but
a way to do
for the
that.
LED has to be fairly narrow so the light doesn't leak sideways.
Yeah, you could do that with a very small pinhole.
Yeah.
And if you put it along the rail side, because what we care about is rail size, and you can only get a few thousandths of an inch before you're going to have either cosmetic as a trade jumps as it comes off turntable, if not derailment. But if you didn't paint the side of the track, like most of us do, you could pretty easily shoot laser down the side of the track, and if it had a disturbance at the break point, it would be pretty easy to optically determine it if you had a shiny surface to aim the laser down. But I'm not sure with painted rail how well that laser is going to align down the side of the rail.
I think,
well,
you know,
could do
unless
it down in the pit itself, though.
Yeah. Between the track,
unless there's not
have the light.
unless there's not a place to actually, unless it's located in a place where you can't actually see it, there's probably nothing better than your good old eyeballs. Depends on how precision your controls are. You know, if you have a push button that, you know, will hold it down and it picks up speed, or if you just tap it, it's only moving. And, you know, the stepper motor has the ability to move a very small amount at a time and a very precise amount. You know, it's an exact amount, unlike a servo. Servo is, but there's inherently slop in servos. But Andy brought up the good point that I forgot of when we first started talking about this tonight. And I know we touched on it last time we did stepper motors, and that's it has to be re-indexed every time you turn it back on. So you have to come up with a method of re-zeroing it, so to speak, so it knows where it is. Because if I moved it, let's say 25 degrees left, and I turned off the layout, next time I turned it on, that would be the new zero. So you wouldn't be, if you wanted to do any kind of indexing or anything like that, you got to go back to thinking you have to re-zero this every time it would lose power.
Well,
AKA
you know,
turn
what
it off
a program is with that indexing is every time you restart the program, you have to be able to say what's the home position and go to home position.
Right.
And you've got to have a way to actually determine that, because a stepper motor doesn't actually have a home position. So you would have to have some kind of sensor.
And you have to write the position somewhere.
Like a contact switch or a closure switch, so that as it went back around, it could go back to that position. You go with a magnet to read switch as easy as anything. But the problem is, as we all know with model railroading, everything expands and contracts. The metal, the wood, it all moves. So if you don't have some way to double check the stepper motor, I feel like you'd spend a lot of time calibrating.
Well, all right, my mic's live so everybody can hear me. Yeah, I don't see why you can't do it like you do in CNC programming. You always have a home position. Everything starts from that home position, all measurements and everything. So just before you go shut your layout down, you just write a piece of code in for the turntable to always go back to one specific position you can call 0. So when you turn it back on, that's your 0 point every time it starts up.
But if you turn the power off, the code won't know to do that. Right?
Well, what you'd have to do, but you can remember a state in memory. So what you could do,
and that's what I'm suggesting for that state.
Yeah, so if it returned to home like it's supposed to, then you write that state and shut down. If it didn't return to home, like if you have a lightning storm where the power goes out, Then the next time it powers up, it knows it has to go home.
Or you have to use capacitors to hold enough power for it to remember and store and go to home position.
Yeah,
And
I actually
realize
have a
it
really
lost
good,
position, lost power.
I got a really
before it
good
does it.
document on how to do that with 4 capacitors, 4 cheap capacitors, 30 cents. And they were specifically doing it for a Raspberry Pi. Arduinos don't really care if you pull the power out of them, but our Raspberry Pi is running a full version of Linux, don't really love that. We can apply the same idea to our Arduinos, put a couple caps in line.
On it. That's
and
right.
anytime it lost power, it would be able to execute whatever code prior to those caps draining.
Right. And you have to be able to sense the, depletion in power.
Right. to
Yeah,
know
that's
that
that's
Turn
pretty
the
easy.
turntable too, though. You
Yeah,
gotta have
that's
more
true.
power to turn the turntable to home
Unless
position.
unless it's separately powered at that time. But
We got Greg Hines. He was talking about his turntable and what he does, but he said that he can't get into the room tonight to show this off. So, tell you what, Greg, if you can, the next Arduino show is the 21st of June. I'm sure Chris wouldn't mind you coming on the panel and showing how you do your turntable, if you want to do that.
yeah, or if he's got, if it's because he's not at a computer where he can show it. Otherwise, you can send him a link for the panel. We have room on here yet, so.
Yeah, he just can't get into the room tonight. So,
Okay. Well, yeah, I'd love to do that. Shoot me an email, Greg, mrltrains@gmail.com, and I'll make sure I leave room for you on the next show. To show that, because that'd be good to see. The other thing is, going back to our other discussion, it really boils down to the simplest thing to do would be the 2 push buttons, and just, you hold down the button, you do your own alignment. That really solves all the problems. You can leave it in any position you want when you shut down the layout. So if you basically had 2 push buttons, or even one, if you just had 1 push button and all it did was go left, obviously you'd spend a lot of time going round and round. So you solve that problem by adding a second button that allows you to go right, aligning left or right. So, you kind of start thinking of it logically in building blocks like that. So you start out the most simple thing to the most complicated.
yeah, hang on a second. He meant he didn't know how to get on the panel right now. So, can you check your email right now, Chris? Or, no,
Yeah.
can you do that? Okay. Give him your email address one more time, Greg. Send an email to Chris, and he will email you the link to the show. And all you do is click on that.
So my email is mrltrains.com. mrltrains@gmail.com.
Yeah, we'll see if we can get him in here. Then once you get the email, Greg, all you got to do is click on that link and it'll bring you straight in.
And I remember we used to do this with turnouts. Interrupt me, Johnny, if you need to for this to get him on here. That's going to be interesting to see. But I remember we used to have turntables where you just pressed a button to go either way. I actually used a momentary contact switch. I can't remember if it was like Fleischmann or Roku, but I had a turntable once that was like that. The problem is you had to remember how far away to let go so that motor could slow down and make it stop, which was somewhat annoying to get used to.
And then you have to bump it, right? Like, zzz, zzz,
yes.
zzz.
Yeah, there was a whole lot of that back and forth. So you really have to go back and you have to have the left and right, because if you overshoot it a little bit, then you're going to stand there holding the button while you say various words in various languages to wait on the thing to circle all the way back around. So you need to be able to go but left and right, and a little toggle switch that has 2 positions, center off, momentary contact, 2 positions work really well if you didn't want to index it. For table, indexing is a requirement. I have to figure out how to index it. I've got an idea, but I haven't tested it.
Bachman's motorized turntable, what they do is they actually lift the track up slightly and then it falls into position. When it falls in, it makes another contact and it stops it.
So it's a mechanical.
It's
a mechanical.
Semi-mechanical and electrical all at the same time. So you can hear the motor.
How
when it
much?
falls into a little lip, that's when it's lined up with the tracks. They have pre-done positions for the tracks, right? They're pre-built in.
So if you're going from track 1 to 7, it'll skip over all those tracks in between and just do the drop down into the.
No, it goes one track at a time, right? You got to go to each track. It goes up, it goes in, it goes up, it goes in. You can continue to hold the button down, but once you see it fall in, you let go and it snaps into place.
Yeah, I like the idea of either a rotary switch or a bunch of push buttons to just tell it what track to go to. But
yeah, so you've got a bunch of buttons on each track lined up. You just click it, the one that you want. And each button has identified its own address, right?
Yeah, a couple of comments here. Steve Structures, he said, I've seen a solenoid used under the turntable and a hole in the pit wall that the solenoid pin would go into to align the tracks. The professor, how you doing, said indexing discussed on MRH within the last few months. That's because the TT uses a mechanical Geneva indexing. And Greg said email sent.
Yep, and I just forwarded it back to him. So let me know
Okay.
if you don't get that in a minute or so.
All right, so I'll shut up and y'all go back to talking.
So if you guys want, we could just, if you want to build something, we can start build something. But if, we're having a good discussion, if you guys want to continue having a good discussion, we could do that too. Or we can kind of do a little of both. We can start putting together a stepper motor again and then starting to actually try to do some of these different things. I think the best, if we work this in a logical sequence, you could start out by building the stepper motor, getting it hooked up and getting it working with a push button. And then we could start experimenting with something to use for indexing. Because I think, at the end of the day, it would be cool to have. It's not necessary, but certainly to get beyond the Roco Bachman type turntables where it's just push the button left, push the button right, and then jog, 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 certainly some kind of an alignment index. I've seen it done with other systems where they use decoders.
Here's how time.
But there again, it's got to rely on something to know where it is. So, it's a matter of how does that decoder know where to turn it to? So, trying to think of the name brand. One of the turntables out there basically is addressable through your DCC system via decoder, but it also indexes to the tracks that you want. Yeah, it could be just a Walters.
Walters has wood, but the wood that I'm really fond of is wood that I think Miles actually pointed me at it. But they've got a wood base and a hydrocal. I can't remember what brand that is, but you've got to do your own indexing for it. They sell a system, but it's much more manual, like what you guys were talking about doing manually. And in my era, that wouldn't be appropriate for it to be manual. It's 50. They were fairly optimized. I found a lot of comments about how to index these things, but and there's some mechanical ways to do it. A rotary encoder seems like.
Yeah. Okay. Hi, Greg. Welcome.
Hello. How are you?
Very good. Oh, there we go. That looks interesting.
So this is my test setup. You see here. I haven't got the turntable built up, but I use an indexing system here, and we'll just right now I got 3 positions here: input track, and then 2 other turntable positions. But you can set up to 25 different positions right now the way I have it set up. I'll restart it here for you.
So is that keyboard indexing basically? Because I remember we talked about that when we were talking about.
This is a little keypad here. Right now, yes.
I think it might have been Andy mentioned on the last show when we were kind of talking about turntables that, to have a keypad input, or maybe it was Chris Rude, one of you two. mentioned how cool it would be to have a keypad input to just push the button for the track you want to go to. Look at that. Nice. So are those...
So I don't know if you can see the screw head here in this one end.
Yeah.
That's I call that the home end, and this is the back end. And so it's 0, 1, and 2. And so all I have to do is say I want to move that end to the home. I'm going to say 0 and hit enter, and it'll automatically go there.
So what do you use to differentiate which end you want to go there? Does it hit a 1 instead of a 0 for your first digit or something?
So I use the star for the home side and the pound for the back end of it.
Oh yeah. Okay.
Okay.
Good idea.
Very good.
Like that.
Yeah.
So if I want to hit 1, I want to go here and the back end. I just hit the back end and it flips it back to the other end.
Very nice.
So is it using essentially the encoder component of the stepper motor to determine location?
Well, there is no encoder in this stepper. I'm using
its built-in mechanism. Yes.
the actual stepper driver that I use actually knows where it's at all the time. So I zero it once.
Okay.
And after I know where 0 is, then I'm moving it back and forth to where I need to re-zero. Because as
So
you
you
go
zero
around
it once every time you turn it on?
this is like the stepper software that's being used here is like a linear controller stepping software.
So you
Only
zero
when I
it
turn
every
it
time
on.
you power it back up. Yeah, first time you turn it on every time, right?
Right. And so it will remember where it is right now. So when I reset this, it's going to go back here and it's going to re-zero, but then it's going to reset itself back to where it was. So every time you start up your layout, it will know exactly where it is.
So it automatically re-zeros itself too? You don't have to...
Right.
Is it going to go around till it's...
It's going to go around until it finds a 0 point.
And what kind of sensor do you have on there that it knows that that's 0?
This is just a little optical sensor. It just hits that and automatically knows where 0. It resets 0, and now as you can see, it realigned it right back to where it was supposed to be. Now, this is all programmable from the keyboard. I have the...
Nice.
I can, if I hold the star key down, you can see it's starting to blink. That's telling us that we're in program mode. I'm going to program, let's say, track number 3. So, and now I can move it to, I'm just going to pick a generic spot here. And we'll just switch it. If I can move the turntable back and forth, the first time is always the home position that I'm trying to search for, and the second entry will be the back end. So I'm going to put it in this position. If I go and press a 7, it's going to move 1,000 steps in the backwards direction. If I hit the 9, it'll move 1,000 steps in the forward position.
And that's something you have programmed in there to do that, right?
Yeah. So I'm just gonna move it around here.
So while you're moving, Johnny, you said there's a question out there?
Yeah, Professor. If the turntable had to do a one-time calibrate spin to identify position 0 using the stepper motor, on the initial power of the layout, would that really be a deal killer for modelers? Also, he's got down here. Go ahead.
Not for me.
Okay. He's got another comment here, which I think you're demonstrating right now, Greg. He says, so move the unit 45 degrees off, power cycle the electronics, and let's see if it knows it's meant to be at 45 degrees from initial power on.
So right now I'm in the programming for the forward step. I found a spot where I like it. I hit the pound key, and now I'll locate the back end to roughly that same location. Now, this is moving in 1,000 steps. I have like the number 4 moves it in 100 steps, so I'm moving it in much smaller increments. And then if I hit the 1 key, we're talking 1 step at a time. So you can get really, really resolute down to where you want. So we'll just say that's about the same location.
How many steps is your motor in for 360 degrees? Do you know?
This motor out of the box is a 200-step motor. The controller takes it down to 6,400 steps for 1 resolution.
Wow. So that's essentially like the stepper motor, and it looks just like the stepper motor that's done by CNC mill. So
basically, yes, it is.
And it's accurate enough. Not only are they strong, but it's accurate enough to mill metal. It's surely accurate enough for our purposes.
Right.
I mean, I've been thinking about having to do a checks and balances on this with a rotary encoder, but I hadn't really thought about just buying a much better stepper motor.
I just bought, actually, when I bought the stepper motors, I bought, let's see, I don't know if you can see this one. This is actually one of the CNC motors from Zytec. It's a 0.9, or it's an 84-ounce stepper motor. I found out that it pulls way too much current, 1.7 amps.
Wow.
So it's going to hold and turn just about any turntable. I model in HO narrow gauge, so I shouldn't have any problems turning any engines on that.
1.7 amps you could set on it and turn yourself around a few times. So that would turn a G-scale locomotive.
So, I mean, there's plenty. So I wasn't trying to get one that big, but it ended up being that large. Now,
so did you write them?
It's actually stored. I write to a FRAM, which is a electronic memory that you can read and write to, and I've stored that location in it, and now it's always I can always call that back up.
So you didn't change that in your Arduino sketch. You've got that stored in volatile RAM or non-volatile RAM.
Right, exactly.
So there's some concepts here that are, what we were discussing. One that Dave mentioned about using an optical reader to line it up to a home position. That's number 1. Number 2, it's what he's done is great. He's programmed the stepper motor to be by the use of the keyboard to how many steps to fine tune it. So then he can lock those positions in once they're fine tuned and save them. And that's what I was saying earlier. You have to be able to save your home position and the index positions, so you can recall them. So that has to be part of the solution.
Well, if it just, the way he's done it is basically to just remember that stepper position 87 is this point by programming it with memory.
Yeah.
That eliminates all but one sensor. You could use an optical, you could use a Hall effect sensor, anything, so that you have one place to say this is absolute 0. And then take that into account mathematically. So as things expand and contract, you could shift out 1 or 2 stepper motor positions if you had to.
My point is,
Something
he figured us a concept that we're discussing and showed us the proof of concept.
Yeah, that's fantastic. Yeah, like Andy said, if something would shift, you just fix it once until it shifts again. If you have to take a couple steps off or something, but it'll always stay there again until you.
Well, that optical that optical sensor or any kind of sensor that has a single position that's accurate enough, like which you could use a Hall effect sensor or whatever that's relatively accurate, it's accounting for that expansion and contraction and calibration issue. You know, as long as your layout doesn't expand and contract a whole lot across an operating session, which is, you know, which would be kind of crazy. So,
Yeah, that's really nice. So you did all the programming for that yourself, Craig?
Pretty much. I mean, I
Right.
did a lot of looking for different libraries and utilizing the libraries. The stepper library actually has an acceleration and deceleration at the endpoints, so it's pretty good at starting up and then getting to a constant speed and then slowing down.
that's really important. More so than most people figure it is. It looks pretty unrealistic if it just jerks to speed. So it needs a bit of a momentum effect.
Yeah, my initial attempt was to use one of the standard CNC slash homemade plotter drivers, but it ended up that these steppers use too much current. But this was my initial attempt, was to use one of these you know, cards you can just throw on your Arduino and power the stepper motor that way, because you can have your separate input power and then just use one of these drivers.
Okay.
That didn't work out. So I ended up having to get a much larger stepper motor driver to, it's this one right here.
Do that because you have such a big stepper motor, right?
That is correct.
Go back to, I don't know if you watched the show when we did stepper motors, but here's a little stepper motor
Yeah.
driver board, and here's the little stepper motor that we used. You know, these only draw 5 volts, or these are 5 volts. I don't know how many amps. Let's see if it doesn't really say on there, but I'm sure it's not a whole lot. Something
Yeah.
like this, for those of us that are not as advanced,
I'm using a
sufficient
12
with the
volt power
proper
supply.
okay. And I've got for now, I've got a little wall wart, you know, that I use, or you can, but, so for those beginners out there, like myself, could we duplicate what you're doing using a stepper motor like this and the motor driver?
That motor driver, I don't
I mean,
think
is there
has the
anything-
resolution that would you need to get it down there, because it's probably 200 steps. I don't remember if that can do micro stepping.
I do remember when you might be right, because I remember when we did our first sketch with this, one of the problems I ran into was it wasn't responding, or didn't appear to be responding. And what I ended up doing was changing the number of steps, and then all of a sudden it worked fine. And what I'm thinking is that the sketch was originally written for like 200 steps, and I may have backed mine down to like 100, and then all of a sudden it worked, or maybe it was up to 400. I can't remember. Does anybody remember the night we did stepper motors?
Yeah, you were moving it up and down trying to find that sweet spot in that controller.
Yeah.
I do remember we had to adjust the steps down in order for it to respond, unless it was going just by too fast. You had no, you know, you basically got no motion out of it.
It's like 200 steps for the what I have. The problem is going to be that the sense I get, and it seems like Greg confirms that, is it's just not going to be accurate enough. These little cheap stepper motors are great for a lot of purposes. They're accurate for a lot of things, but we need, you know, within, you know, a few thousandths accuracy. And I don't think, I've looked at some of those motors that like my mill runs on, and they're not that expensive. I mean, they're more expensive than these little $5 motors, but
I got 3 of these
That you
stepper
put
motors
that
for
card
like
solution to
$25,
get that accuracy.
$25 or $30
$25.
for 3.
Oh, okay. So yeah, so $10 a piece, less than $10 a piece for a
Yeah.
stepper motor. So
Now
How
this
much was that
controller
driver?
the driver was only $10.
Oh, wow.
So I mean, it's not big bucks buying some of this stuff.
Looks like an expensive piece where I'm sitting.
It looks expensive, but it really isn't. And it's going to drive anything. This controller could drive your little stepper motor that you have, and probably make it work just fine.
So is that an eBay purchase, or is that a electronics
This particular
house,
one
or-
wasn't off of eBay. Yes.
Okay. Okay, I hear R2D2.
Yeah, that's my wife trying to call me right now.
Or is that C3PO?
Or your
One of
stepper
those.
motor trying to reach
I'll have
you.
to call you back.
Yeah.
You know what'd be really good is to maybe you, if
That's
you're willing, share the code either now or the next show, and walk us through some of the techniques that you've used to program this.
Why don't we do? Could you do that right now? Do you have time, or if we gave you a couple minutes to bring it up and share your screen?
Hang on, we got
Yeah.
some comments. Let me
Okay,
get
we'll
my,
go through some comments while you work on that. We got some comments out on YouTube, so go ahead, Johnny. Okay. Don't know if that would solve your accuracy problems though, but potentially it could. Yeah.
Yeah. Boy, it's a no. I guess I'm going to call it a no name. But here, I got some of the information here I can pull up in just a second here.
Maybe Greg can post it on the Google Plus page under the Arduino and section.
Yeah, that'd be a good place to put it because then it's always there.
Yeah.
I thought I had the microphone on. Sorry about that, Professor. Now you're here.
Oh.
Now you didn't quit.
Oh, so everybody missed the comments before, just heard my answers.
No, you were fine. It was me. I still had my microphone turned off. Only you guys could hear me.
That's what I'm saying. Those guys didn't hear the comments, only my answers, right?
Yeah, let me.
So it probably didn't make a lot of sense to them.
Yeah, Professor was talking about taking a 200-step motor and putting a gear head or a worm drive reduction on it. But we're going to get the.
You can probably do that.
Okay.
But your average, I think your average angle of per step is like 1.7, 1.8 degrees.
Professor
And if
said
you don't have a high
1.8.
quality, if you don't
Yeah.
have a high quality gearbox, you could lose some accuracy and repeatability through that gearbox too. Gearbox with loose gears, the repeatable accuracy may be all over the board as far as the precision that we need for a turntable is concerned.
Yeah, Professor is saying 200 steps plus a 4-to-1 gearbox equals 800 steps per rotation. 300 degrees divided by 800 steps equals 0.45 degrees per step.
And assuming no gear slop, that's very precise.
Yeah.
But if you just, I'm thinking locomotive, just take it and, grab your wheels. By the time you go through the worm gear and the other gears, there's a lot of slop, but there's a lot more gears in there probably. But, look at how much you can rock those locomotive one axle back and forth without turning the rest of them. So those are your repeatable accuracy.
I don't know if you can see this fritzing diagram, but this is kind of the breakout of what I have right now.
Hang on, I'm going to put you, all right, you're up full screen, so. We're not seeing a diagram.
So just the Fritzig home screen.
Okay, let's try sharing this again then.
You know how to do screen share? Top right hand corner.
Screen. Yep. Let's see. Let's share the whole screen here.
Yeah, sure. Share the whole screen. There
you go.
There it is.
So this is the stepper motor. It's a 20,000 hertz single axis TV 6600.
Okay.
And it's
a photo.
Yeah. There's no actual fritzing diagram for it. All I could do is put in the actual connections off of the side of it.
So that's all the connections that are on that stepper motor, or is that
correct?
Or I mean, on the controller.
So there's actually only two inputs on it. There's one for direction and one for the stepping counts.
So what is the little board in the center of your breadboard?
This one right here is actually the FRAM chip, and that's
okay.
where the memory is. That's where I write exactly what the last location that the turntable is pointing to, and I write also the locations of every single stop there is for the turntable.
And that's all done programmatically with the keyboard in your Arduino sketch.
Correct.
Hey Chris, I'd like to point out, you remember the other day or last time when we were talking about that real-time clock? Most of those real-time clock modules have memory built right in with battery backup on that memory. You can access that memory exactly the same way you access the clock. The only difference is it's got a different address on the I2C bus in order to access the memory.
And this uses an I2C bus too. And I chose this particular memory because you don't have to worry about the number of writes. This is in millions of writes. I could have used the one that was built in on the Arduino board. There is an EEPROM in there, but you're only limited to like 10,000 writes, and you have to worry about shifting the data through it. So I didn't want to have to worry about it at all. And I think if I remember rightly, this is like another $9 part, so I wasn't worried about it at all.
Yep, that's why I pointed out the memory that's also on that real-time clock, so it would save you from having to buy that memory module that you've got.
So looking at his fritzing diagram, I can see a future show for us right there is that input keyboard pad. I'm going to look through my box, but I do believe I got one of those with my kit.
This one I got. Actually, I go up to we have a Micro Center here, and they have a lot of the parts that I normally get if I need something for Arduino.
Okay, I guess I'm mistaken. I don't see one in my box here. But yeah, that would be kind of cool.
A lot of our kits come with these little remotes, though. It'd be pretty easy to do IR and take that IR codec and do something with it.
I don't really like that flexible membrane one, and I will be hooking this one up here shortly. This is an actual hard button, like an old phone keyboard.
Used to be, absolutely.
Yeah, and I like this one much better. And I'm hoping, if I can get this to work, I'll be replacing it with an I2C module that I'll hook up to the back of it, and it will control the LEDs and everything right off the switch, and I can have it remotely to the Arduino.
Oh yeah,
with just three cable connection to the keyboard, if I can get that to work. So that's the next step.
So other than that, you're very happy with the way it works, or is there something that you're still in development on to make a little better besides the keyboard?
The keyboard,
pretty much-
I want to be able to reset all the connections. Sometimes I might want to just start all over and reset it all. Right now, I run a separate Arduino piece of software to reset the locations.
Okay. But eventually, when you had it set up, you wouldn't want to do that. So
Yeah, and I think cleaning up some of the code. Right now, I'm right on the border of the amount of memory you can write to an Arduino. So I might have to go to a different processor.
So Johnny, did you have something?
Yeah, Professor was giving everybody in the chat a little math lesson, but there was one interesting bit about it. He's talking about the stepper motor and how much steps are in it at 200. But he said also, because we're talking about alignments on the tracks, he said it only takes a 0.5 thousandths offset to derail. So you want to make sure you got good resolution on your stepper.
Well, I think that was Andy's point, that your alignment has to be pretty darn accurate.
Yeah.
For it to work properly. And I think the solution that Greg has, be able to give it little bursts by using numbers to control how much of a burst it gets. The higher the number on the keypad, the more it moves. And so you can do micro bursts to line it up.
So Greg, are you able to open the sketch and share your, let us see, take a little dive into the sketch?
Let me share that out again here.
Not the fritzing diagram, but the actual code in your Arduino IDE.
Yeah.
And Greg, you said your controller is giving you a ratio up to 64,000.
Yeah.
So Professor, what's the math on that real quick?
So it's 0.05 degrees per step.
Of an inch, Professor. He's getting a calculator out. That's okay. Just give him the business.
I mean, if you, I just want to touch on the RAM bit real quick. If you needed more RAM, there are Arduino boards that have a little bit more RAM. I believe the Leonardo has more RAM because it's a 32-bit processor. But if you needed more RAM, and I don't want to take away from a microcontroller because this is pretty perfect for a microcontroller, but the other option would be to use a Raspberry Pi Zero, which are like $5, and that would give you probably more internal RAM than you would ever need to process what you're doing. The only problem is that you're in C right now. You could write C in Arduino and the Pi, but typically a lot of people use Python. So, but I mean, you could always go to a better Arduino board to get that processing speed. The other thing I would limit yourself on too is if you can get away as much as possible from using strings, because strings will eat up your RAM also.
Yeah, they have to hold a spot. But
yes.
If you went to, are you using a Mega right now?
Well, yeah.
No, this is just an Uno. So I mean, I could go to a Mega easy.
Yeah, it's got 4 times the space on it, so you don't have a problem at all. A Mega is also very, very standardized, for based on the same. It's Uno compatible, whereas some of the Diblanov or whatever, I can't speak Italian, or Leonardo, there are some nuances to their configurations. So I try to stick with Nano, Uno, Mega because of the
Plus you start getting into 3-volt logic in some of those too.
Right.
So you have to worry about level shifting maybe.
Yeah. I'm a fan of Raspberry Pis and others, but that there's places for each of these pieces of software. If we're controlling a stepper, you just can't beat the
Arduino is the best. Absolutely.
Yes, well, I mean, it's just real time logic. So
I was just kind of giving them options to say, this is another option to go down too. But the Arduino is the best for stuff like that.
Yeah.
I love the Pis. Absolutely love them.
And I agree. And I agree with Andy on the Mega. It's just that you get it's not a big deal, but you have all those, you have like 54 I/O ports on the Mega, you're not going to use that many. But you know what? I buy my Megas for $10, so I mean, it's not not a big deal.
And they're larger. If you were trying to stash it in something small, that would cause an issue. But if you hide it under the layout, the difference in a Mega and a Nuno is not that significant.
I like the Mega.
If you're trying to build a self-encapsulating turntable unit that doesn't require you, then you'd probably want to go with even a Nano and then use that memory chip as a solution.
Yeah, but I think the problem is the code. So
the code is almost filled up memory.
Yeah, it's the program that's the problem. So even if you went to a Nano, it wouldn't really solve your problem as far as what he has. So that's what Andy's saying, is that the Mega would be the next best step.
Yeah.
Because it's got 4 times the space on it.
Right.
It's also got a little bit better computation. Also, I've had some issue with RTCs lately. I've been working with some audio, trying to get high quality audio out of Arduino, and the RTCs the real-time clocks have some particular nuances, and I've found it better to just query an NTP server, network time server, like your computer does, to get fairly accurate time. Because of the load that an RTC puts on your Arduino.
Mm-hmm.
And the best with the if you went to the Mega too, if you wanted to, you can also put an LCD on there and run an LCD, so you can have the output right at the layout for what the program's doing too.
Right.
Because
got to show us.
Yeah. So let's see your sketch there, Greg.
So. Pretty simple. Use a keyboard. These two libraries, just the keypad libraries. I wrote a flasher library. That's just to control the LEDs. I use the A-stepper library. This has got built-in acceleration, deceleration. It's a great library. I like it. Took me a while to figure it out and how to zero it out. But I got it. And then I use the Adafruit FRAM chip. Just a couple
before you go any further, let me ask a question here from a dummy standpoint. Talking about filling up your RAM, is there a way to go into the libraries and remove unnecessary portions of it, create a new library, and save yourself some memory? Is that possible? Is there things in the library that
you might be able to do that? I don't know.
Is there stuff that you're loading that you'll never use?
Well, you have to be able to go through the code line and guarantee that any portion of the library is not making calls to other sections in the library.
Okay. Just curious. That could be one way to cut down some.
Make your own library, a combo library.
This library here is not your standard Adafruit FRAM library. This writes 16-bit words. So everything is in binary, being written to memory into this FRAM chip. So that can be a little bit daunting if you're not used to writing. It's not like writing a text file to a memory card or something like that. I set up a bunch of variables, which ones are hooked up to which pins and things, pretty standard. This allows me to turn on and off debugging mode. Initializing a bunch of variables. I initialize the arrays for the stubs. The stub location, the front end of the turntable, the back end of the turntable. I set up the FRAM. You set up the keyboard and the memory. When I push this button, which is the number I'm going to get back. Call the keyboard. Call my libraries for the flasher, set up the parameter on the blinking. Configure the stepper motor library. Then we start checking to see, can I see the FRAM out there, the memory FRAM? If I can't, you know, stop and just go into a permanent loop. I zero out each one of the memories. I set it to 999, and then I load. Then I'll do the load, so I know where it's all set to. And then I set up my listeners for the keypad, so it's reading the keypad. I set up the pin mode for the home position for the stepper motors. I set up how fast I want it to go. And then I tell it to go find the home. That's the very first thing, is go set up the program and go out and do a home command. Then I check to see if there was anything in the FRAM that already is configured. If it doesn't find a configuration set up in it, it automatically drops you into programming mode. And that's just the setup part, and then we get into the loop and we start reading the keyboard. And it just loops through that keyboard process. So I'm just sitting there looping all the time through the keyboard and seeing if anything's pressed. And so we just loop, and the stepper motor is always being queried to see if it needs to make a motion. And that's one thing that's critical about this particular stepper driver. You wouldn't want to have put any real delays in the loop. If you do that, it's can screw up the stepper. So when a key is pressed, I can find out if the key has been pressed for a long time. That's how we determine if the star key is being pressed and hold. I can say, all right, I want to go into programming mode, versus just pick the stub and which direction do I want it to go. Then I call, you know, if I want a stub, I just call the get stub routine, and it goes out and it will move the stepper motor to that. So I figure out which direction. I figure out which direction is actually the shortest, and that is actually the problem, is trying to figure out which is the shortest way to turn the turntable. And these are for the programming mode to move the bridge. You know, do I want to move it just 1 step versus 100 steps versus the 1,000 steps?
Previous comment on determining which is the shortest way to go.
Mm-hmm.
There again, if you're looking to maybe remove a little code, if you get so to remove that, and it would always just go, say, the counterclockwise or clockwise, rather than trying to figure out the shortest way. I mean, that looked like quite a big chunk of code for that operation.
That, I think, if I was, let's see here. In this particular part, this is actually, I misspoke. This is actually for getting the program for the front and the back.
And Greg,
Okay.
you said you haven't programmed it to figure out the most efficient turn, right?
It is right now its most efficient turn.
Okay.
But that's that's a nice option, but it's one that you could do without if you always just had it go clockwise or whatever.
I'm gonna
Cool, you're able to figure
apologize.
that
The
out.
dogs may start barking now. Family just got home. Let's see, what other points can I push out? There's a lot of serial prints, and that's part of the cleanup I'm going to probably do, and that's going to probably save a lot of memory, so I don't. So we can get with a smaller, keep with the smaller Uno form factor.
Well, you could put it under debug mode, correct? And that would take it out of the line.
I think it takes it out, but it doesn't actually take it out of the program code.
Still compiles it in.
Yeah, it's still there.
Yeah. Unless you just comment them out, then it's out of the code.
Yes, right.
I like the cleanness of the code.
I tried to make, I'm a semi-programmer. I call myself a hacker, but I try to keep it as clean as I can. Break it up into sections as to make it more readable and understandable.
Well, that's pretty impressive. How many hours do you think you got into just the coding?
2 months. 2 months to figure it all out. Get all the hardware in and make it all work.
Well, that's really cool. I know this is a little beyond beginners, but it's really fun to see this, you know, because you can go out there and see a lot of things on the internet, but you don't get to see it like this, where you get rated, you get to see the code, you get to, you know, ask
Greg,
to put
do
it
you
all
mind
together.
sharing it on our Google Plus page? The Fritz diagram and the code and some of the links for the hardware?
Yeah, I can probably do some of that. I want to do some cleanup before I get ready to release the code, though, first.
That'd be great. Thank you, Greg.
Yeah, thank you very much. So that was really cool. I appreciate you jumping in, and you know, same invite to anybody else that's out there. You know, if we have room on the panel, and we'll get you. We're not trying to lock anybody out or anything. We want to all get in here, and apologize for not doing any hands-on work tonight, but I think this was a lively discussion and very enlightening. And change subjects just a little bit now. The other thing I wanted to cover tonight for sure was kick at the speedometer thing. I've, you know, still been looking, and I'm finding there's all different speedometers out there. I haven't found the one that's personally suits me as the best project for us, but we could go anything from simple to complex, built into mobile. I guess I'm looking for feedback from you guys on exactly what kind of speedometer you want to do. Do you want to do one that's based on infrared and it's in between the tracks, or do you want like more like an AccuTrack type speedometer that's a mobile one that you just set over the tracks anywhere you want to be able to do, you know, something very simple but maybe doesn't do everything we want it to do, or something more complex that has all the features we would want? You know, what are you guys looking for in a speedometer?
I would think that, you know, if you started simple and then spent maybe 2 shows making it more complex, and the next one coming back and adding on, that might be more value driven.
Okay. Because I mean, we could start out with something that's just on the breadboard, or we could go ahead and make something that's usable right away. Although we're probably going to end up making it on the breadboard anyways, and then it would be up to you to buy another Uno or a Nano or a Pro Mini or something to, you know, actually install it on the layout. But my personal preference would be something similar to the AccuTrack, which I'll show you. 1 second to go.
Yeah, just watch and
So for those of you that haven't seen one of these before, AccuTrack speedometer, when you look in the back of it, right here is your IR pair, and there's another one over here. And you know, set this over your track and the train goes through, it breaks the first pair and then it breaks the second pair. It's got a digital readout right here. Let me turn it on. This particular model is switchable from N scale to HO scale. And if you look online, there's a guy out there who's done one of these very similar to this with Arduino, and it even has more functions than this one has. But it has quite a few parts. So, you know, to me, my preference is to make something mobile, but down the road, I wouldn't mind seeing something built into the tracks either. So, you know, how elaborate you guys want to get and how much money do you want to spend on it, I guess is the big question for speedometer wise. Any comments?
I actually think the mobile is probably a better idea, because I like the fact that you could take your unit at any time you want to, move it wherever you want to, bring it to somebody else's house. You know, you do a lot of speed matching. I know that, and it comes in particularly valuable for you because you can move it onto any section of straight track and get it to work. So I think something
because there's
mobile is
really
good.
There's really two functions for speedometers. One is for speed matching, and you're exactly right. Mobility is king there. But then you have another situation where on your layout, you might want a speed limit. You know, you want operators to get some idea how fast they're going, so you actually build it in. You know, if you have that, I wouldn't suggest building it in if you're going to use it for speed matching, but it doesn't mean you couldn't. For instance, on my layout, when you're climbing the 2.2% grade of the Mullen Pass, well, a heavy loaded coal train only does 12 to 15 miles per hour in real life. So, you know, 12 to 15 miles an hour to an HO scale modeler, it's hard to really tell. I mean, you get guys that are trying to run 20, 30, 40 miles an hour thinking they're running 20 miles an hour, 15 miles an hour. So to give them an idea how fast they're going, you could turn on this speedometer. If it was built in with.
I think what you're really looking at though is the mobile version is literally just the same as a built-in version. With the total cost of parts, you know, you're looking at a little Arduino, or you start getting these Pro Minis for $3 a piece, and IR receiver transmitter pair for, you know, $10 for a, you know, 24 pair, and a couple of odd cents. You know, you're looking at $5 for the total cost of a speed. So you could put in any number of built-in speed units that you wanted to, because you can get those little LCD screens for $3 or $4 a piece too. So under $10 total, you're covered.
Yeah.
And I've got a theory on how to do feedback from them as well. So you could even bring it back for calibration purposes or to display them. Like I use iPods, so you could bring it back to an iPod for display. You know, there's a lot of ways to skin that cat, but being able to build it into the layout. I know me and Chris talked about that before too. Both of our layouts, being helper district layouts, extremely slow speed is kind of the weird excitement at a certain point of the layout, and having it built in is just a prerequisite to me.
Yeah, I had to laugh because I started re-speed matching all my locomotives, so they my top end is about 44 miles an hour, but the first 12 speed steps of 28 are 1 mile per hour per speed step. So, you know, I had my first guys coming over to run when I had my golden spike party, and then one guy's first comment was, "There's something wrong with this. It's running really slow." You know, and he had it cranked up to about 16 speed steps out of 28, so about was doing about 20 miles an hour, but he thought it should have been going way faster, you know. Like, nope, that's the way I set them to run. Get used to it.
Got a comment.
Okay, Johnny.
Ron
Has a comment.
Perry, just another scale mauler. He says Steve Hoffmeister built a speed matcher, and he's got videos on YouTube. He also said that's Hoffmeister with 1F, not 2.
Okay. Thank you, Ron. Appreciate that input. We'll go out and take a look at that. So, one of the things I'm trying to
that you could have built in and then plug it into your layout versus making it mobile.
No, I think you could probably, like Dave said, you know, the guts would be the same. It's just what do you mount it in? Mount it in the layout, mount it in a piece of, you know, bent up plexiglass like this, or whatever you really wanted to do. You could mount, you know, it could be wood for that matter, you know. But the point being, you'd have to make sure that you know the exact distance between the two pairs, because that's what everything keys on. The time and distance, and then the mathematical formulas based on that for the scale that you're running. So one thing that was kind of weird about this one I noticed lately was speed in a different direction. And if I went through, you know, forward this way and then backwards this way, it might run slower backwards. I think, oh, that's just, you know, reverse trim. Go ahead and set that in your decoder. But then I found out if I literally flip the locomotive around, run it through the same way, what was backwards is now forward, and it runs the same speed as before, and the other way is slower. It's literally not the locomotive. It's not gear train bind or something in the locomotive. It's actually something in the speedometer itself. And so then I started thinking, well, is it different lighting conditions depending on where I set it on the layout? You know, does it make or break one beam different than the other because of ambient light conditions? And I've tried everything to narrow it down, and I've just come to the point to realize that there's something wrong with one set of those. There's some difference between the two IR pairs that or in the programming, that when one makes and then breaks, it doesn't measure the same as if you go through the opposite way. It's kind of weird. So it might be programmatic.
I suspect what it is. I suspect what it is, Chris, is it's probably the height of the IR sensor. It might be set at just the right height that when you go through one way, the handrails on the front of the train break it, whereas the height on the other end might be a little bit different, and so it doesn't break at exactly the same time.
Well, I thought the same thing, and that's why I started testing with a box car. But then when I realized, okay, let's call this the A end and this the B end, okay? So if I go forward with the locomotive from A to B, I might get 10 miles an hour. And then when I come through backwards, facing the same way, it might be 8. If I literally flip that locomotive around 180 degrees and back it through from A end to B end, I still get 10 miles an hour this way and 8 miles an hour that way.
It may be that it's reading one sensor first and the second sensor in sequence. And it's always designed to read in that sequence, and therefore you get a delay on the other one. You get a differential.
That's what I'm thinking. It's got to be almost something programmatic, because I literally
right. It's testing the one sensor first. It's assuming the direction. Does it have an arrow on it to indicate the direction you need to take it?
No, it'll do either way.
I mean, it will do either way. But do they have a recommended direction?
No, they don't. I ended up putting that arrow on there too. So what I do now is I run when I speed match, all my locomotives are speed matched with the front end of the locomotive going the way the arrow is. So then it's consistent.
What would be interesting is try with a different unit.
Actually, my friend just bought one and he was running into the same thing. So we were going to get together and try them side by side, and we haven't done that yet. So,
so it may not be a bad sensor or a slow reacting sensor kind of thing.
That could be programmatic.
Yeah.
Processor speed.
So why is it consistent? I mean, if I literally left the locomotive the same direction and turned the speedometer around 180 degrees, it does the same thing. So consistent in direction. One direction is faster than.
It's reading one sensor first and then the second, and it's designed to read them one way, not the other way, necessarily in that sequence.
I want to contact AccuTrack about that. See if they have any ideas.
Maybe they have a software fix.
That could be. This is a much older one. I've had this for probably 10 years now.
AccuTrack 3.0.
That's what out. Is that what's out now?
I don't know. I'm being facetious.
For all I know, they do have a newer model. You know, the newer one is taller than this now, so you could.
Chris,
guys that want to leave it sitting out on the left. Yeah, yeah. There's no port unless you can program through a AA battery.
Yeah.
So, anyways, I guess that was the feedback I'm looking for. If you guys still want to do the speedometer program, I guess we can start way up, or we could just go ahead and do the deep dive and do, because there's the guy, and I think, I apologize if I get this wrong, but I think he may be Russian.
Yeah.
He's got a YouTube and some other places I've seen it. And he even prints out a label that looks similar to this, but his has more functions, and the LED readout displays more things than this one will.
Yeah, and he's not doing it.
He's done a really nice job, but
yeah. So, personally, I think if you start with a basic first, breadboard the concept out in one show, you get it covers a lot of audience and allows them to practice at it and see how it works, the concept, and then you can always go retrofit it with the wires and a circuit board and PCB and so forth.
Okay. So, excuse me. Anybody, you guys want to continue a lively discussion, or do you want to just on and I'm still under the weather, so my voice is going pretty fast here, and I think I'd prefer to hang it up for tonight, but we can certainly, either you guys can keep going, or we could have a lively after show. Let some other guys jump in that are out on YouTube right now. But I think I really appreciate you showing that, Greg, and anybody else that's out there that has something like that to show off. I mean, I love seeing that stuff. It's like I said, you can always go out to YouTube and see stuff, but you don't get to see it like this. You don't get to ask questions, and you don't necessarily get to see the code or all the other nuances that Greg was able to show us. So this is a great forum for kind of show and tells like that. So I greatly appreciate it.
You know what the next issue of the EMAG coming up is about, right?
Apologize, but I don't. I'm getting behind on stuff here.
Well, if you were to take a wild guess at it, you'd probably say control systems and Arduino and Raspberry Pi, and you'd be correct.
So we're going into the rabbit hole. Sweet. All right. That's cool. Looking forward to that issue. Surprised you don't hit me up.
I'm actually been thinking about how to design the cover. I might give you a call on taking some shots for me.
All right. Well, sounds good. Appreciate you guys all being in here. And Johnny, did you have some more comments or questions yet before we pull the plug?
Sure. Sure, I can.
All right. So I'm going to let you close her up, Johnny, then, and hope to see you guys around. I've been so busy. I just haven't been online much lately, but I'll try and get my nose into some more hangouts on some of these nights. And I know there's other guys out there that, would love to just talk Arduino in general on some of the off nights. So maybe it wouldn't hurt to get some just informal hangouts going on Arduino too. So thanks for watching, everybody, and thanks for being here, guys. Johnny, close her up.
Alrighty. All right, well, appreciate that, Chris. It was definitely a good show. And what did I do here? Oh, okay. I'm messing myself up here tonight. But anyway, go to YouTubeMobileBuilders.com. There you can check the schedules for the Tuesday, Wednesday, and the live show. Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern. The Thursday weekly show and the live show are at 9 o'clock Central, 10 o'clock Eastern time. And be sure to go and click on the e-magazine and sign up for email notification for when the next issue's coming out. JD and his team do a great job of putting it out and making sure that it's ad-free and also a free publication for the community. So we have a number of community people that are contributing to the magazine. Boy, I'm having a hard time with that word. I guess I need to get a few lessons from Big Bill on those hard words. Yeah. Get away from delicatessen. But also, we've got the fine scale build next week, June 13th. That's with going to be Andy's the host. We got Miles Hale, Ralph Rossetti, and Barry is off this month. He's got a lot of stuff going on. Plus, he's getting married towards the end of the month, too. And I think Andy's going to have a special guest on the show. So you might want to watch out for that show and be sure and be there. Should be pretty interesting. Also, next week on the 17th, that's a Saturday. That's going to be the live show with Big Bill. He didn't tell me if I could say who the guest was or not, but I can tell you, I think everybody's really going to find this guy pretty interesting, especially if you looked at his post here in the G Plus and YouTube. And also, I'll be hosting that since Barry's taking the month off. So that means I get an extra paycheck this month. Anyway, I want to thank everybody for being on the show, being in the panel here. Appreciate everybody in the chat. And with that said, we are going to go ahead and sign off. Have a good week and a good weekend. And we'll see you on the June the 13th for the fine scale bill. Y'all have a good night.